Hi guys, today we're going to be going over the topic of finite differences. To start off, let's begin with a basic example. Let's say we have a simple series like 3, 7, 11, and we want to find the next term in this series. In the concept of finite differences, the way we will do this is by finding what we call to be a difference series of our original series, which I'm going to denote as this little symbol delta here. To find this series, what we're going to do is we're going to take each two consecutive terms and find their difference. So we have this 3 and this 7, so their difference is 4, and this 7 and this 11, and their difference is also 4. Notice that this series is constant. This indicates to us that this pattern will keep going and the rest of the terms will also be 4s. And notice that can now help us to deduce this term that we were looking for originally. Since we know that the difference between these two terms is 4 and this one term here is 11, we can deduce that this term here is equal to 11 plus 4, which is equal to 15. Now, this might have seemed like a silly example since this is pretty easy to see anyway since we're just adding 4 each time. But let's say we take a slightly more complex series. Let's say we have something like this, 3, 6, 13, and then 24. Again, we're going to take our first difference series, which we find to be 3, 7, and then 11. So what's this here? Notice that this time, this first difference series is in fact not constant. What this indicates to us is that we need to find a second difference series, which I'll denote by giving the delta term an exponent here. This time, we're just going to find the same difference series, except we're going to start with this series here. So we take the 3 and the 7, and we find their difference to be 4, and the 7 and the 11, and we see that their difference is also 4. Now look at this. This series is now constant. So now we can infer in the next term to also be 4. Now again, like what we did last time, we can find that the next term in this first difference series is 15. And based on this, we can work through our different series and find that this one, this last term that we're searching for, will in fact be 24 plus 15 is equal to 39. This demonstrates how finite differences can be useful to find successive terms of series that may not be as simple as a simple arithmetic series. So with that, we're going to move on to our first problem. In this problem, we're given a set of x, and we're to find the value of this complicated expression here based on these three expressions that we're given. Now we might notice that these seem to follow a pretty obvious pattern. The coefficients of this first equation are all the squares from 1 through 7. The coefficients of the second equation are all the squares from 2 to 8, and then 3 to 9, and then finally, for the equation that we're trying to find, 4 through 10. Now this makes us think that perhaps this is a series that we can analyze using finite differences. And in fact, we can. Let's take these values that we have on the right here, 1, 12, and 123. First, we'll find our first difference series. We'll take the 1 and the 12, and we get 11. We'll take the 12 and the 123, and we'll get 111. Now, again, these are not constant. So we're going to move down the chain one more time and find that 11 and 111 gave us 100. Now, you might be asking, how do we know that in fact this 100 will continue on? And this is the constant series. How do we know that we didn't need to go down one more time to find the constant series? Well, for that, we can look at these coefficients more carefully. Notice how they're quadratic in their nature. They're squares. They're not growing by factors of a cube or a fourth or etc. Thus, we know that this series has to be quadratic, and thus this second difference series must be constant. Based on that information, we can fill in 100 here, and then work our way upwards to find the rest of the terms, getting 211 here, and finally getting our answer of 334. Notice how we were able to skip all of this algebra and polynomial stuff just by approximating these series using finite differences instead. Let's move on to our last problem. Define a hotel elevator cubic as the unique cubic polynomial p for which p of 11 is equal to 11, p of 12 is equal to 12, p of 13 is equal to 14, and p of 14 is equal to 15. And we're asked to find p of 15. Well, notice this one important thing here. We're given a cubic polynomial, but we're given 4 data points. Just like with our quadratic polynomial, this means that we can find the rest of this series. So let's begin. We'll start with our first starting data, 11, 12, 14, and 15. And of course, we want to find the next term in the series. 11 and 12 gives us 1, 12 and 14 gives us 2, and 14 and 15 gives us another 1. Now for the second order difference series. From these first 2 terms, we get a 1. From these second 2 terms, we get a negative 1, as now we're going down. Finally, for our last third order difference series, we get minus 2. And again, we know that this final difference series has to be constant because we know it's a cubic. Thus, now we can fill in negative 2 here and start working our way back up. We find that this term is minus 3. This term is minus 2. And finally, our answer is 13. And just like that, we're done. Notice how we were able to simplify this complex polynomial problem with this basic use of finite differences. Thanks for watching and have a great day.